Okay, so I just hit record. I'm just going to mention for the purpose of my YouTube video that last day we did functional groups. So today we're going to look at functional groups on different atoms, or sorry, different molecules. Okay, so maybe you guys in the chat can help me here. Let's start with, well, okay, let's do a few things before we talk about functional groups. This, of course, is our benzene ring. This makes it an alkene. Well, sorry, it's an aromatic compound that has a double bond. I shouldn't say it makes it an alkene. We have an aromatic compound that also has a double bond. This is a very long, large organic molecule. So you see a lot of things like some organic molecules, you can see alkenes, alkanes, and alkynes on the same chain. Right? So this is benzene ring. It does have a double bond. I don't consider those functional groups. Functional groups for me are things with like oxygen, sulfur, nitrogen, or even some of the halogens. So what functional group is this one? The one I'm drawing arrows to. What in the chat or out loud? What will we call this?
Amide.
Amide, exactly. Amide or amide. I say things weird because I'm a weird Canadian, but amide, exactly. Okay. Now, these two over here are not the same. Like, don't say, I don't even know what you would call it, but they're not combined. They are not on the same carbon. They're not next to each other. There's a few carbons in between them. So they're completely separate. So what about the top one on the left? Alcohol, someone said in the chat, and Saif said in the chat, alcohol and ether. And you are correct. We have an alcohol on the top. Oops, sorry guys. And an ether on the bottom. Cool. So a little fun fact, like I was mentioning, so okay, first let me just mention, if this was on a test, wink, 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 you don't have to tell me about the alkenes or the benzene. This would be a 3-point question. 1, 2, 3. I would have 3 blanks next to it, and you would have to fill in the 3 blanks. Benzene and the double bond, we're not going to consider them functional groups. They definitely help with the reactivity of this, but, or well, I shouldn't say help, but they are factors in the reactivity, but not functional groups. So I mentioned a few minutes ago that this molecule is responsible for the heat we feel when we eat hot peppers. You know, what you might see on the internet, or if you've, you know, ever done some research on this, one of the best things to eat in, or drink, I guess I should say, if you eat hot, spicy food is milk. And it's probably why a lot of, you know, Southeast Asian dishes, like especially like Indian dishes, come with raita or yogurt. It really helps with the heat. It's like in America when you get buffalo hot wings and they serve it with ranch or blue cheese dressing. The dairy in milk, yogurt, ranch has, and I think it's casein is what I'm talking about. It has a chemical, or I think it's a protein, casein, and that helps dissolve capsaicin. This is not soluble in water. So the fat, I guess it would maybe even be the fats in the milk, help the capsaicin dissolve and can wash it away from your tongue. So if you guys are ever out eating spicy, you know, wings or curries or anything, you know, spicy whatever, I like spicy ramen, milk is probably the best thing to drink. Definitely not water or Pepsi or Coke or whatever. You'd probably want something milk-based. Although I gotta say, milk and chicken wings don't really go for me. I'd rather have a Pepsi or something. All right, aspirin. You guys probably all have heard of aspirin. Aspirin is the trademark name for this. This is a painkiller or an anti-inflammatory maybe. Again, I'm not a a doctor by any means, but aspirin is a painkiller. So you take for a headache or something like that. So I'm hungry too. I'd love to have some biryani or anything really. I see in the chat there's spicy biryani, really good. The college has, for me, I don't know, you guys probably might know more about this than I do, but the college, I like the biryani there. Anyways, okay, so functional groups. This guy has two functional groups, right here and here. Again, we do have a benzene ring, a lot of chemicals found in nature or in food that we eat really tend to have aromatic rings in them. So the aromatic ring doesn't count. In the chat, guys, what do you think we have here? What functional groups? And you can say out loud as well. Saif says carboxylic acid and ester, and I think you're right. Right, you might say, oh, well, this is an alcohol and this is an aldehyde. But remember, when they're together next to each other, it's a carboxylic acid. So carboxylic acid. And then ester, not ether. Even now, sometimes my brain mixes those two up, ether and ester. If you guys are curious, maybe you can't remember, ether just has the oxygen in the chain. An ester has this ketone or the carbonyl group attached to it. And you don't need to know the names specifically like carbonyl or hydroxyl or anything like that. But, and just remember, for the people who weren't here yesterday, or maybe if you weren't paying perfect attention, I'm going to give you a list of all the functional groups on your D2L. So you don't have to memorize this. All right, I think I have two more. This guy has three functional groups. This is another one of my favorite chemicals, vanillin. Vanillin, so obviously one of the compounds in vanilla. So a lot of desserts or ice creams or gelato, whatever you guys eat that has a vanilla flavor, typically would have vanillin in it. So three functional groups. Feel free in the chat to let me know what these three functional groups are. We've already seen almost all of these. It's hard to get too creative. So anybody want to tell me which or what functional groups we have? So the chat. So alcohol is one of them. Ether is one of them. Yeah. Saif, you're a legend today. Alcohol and ether, exactly. And we're missing one more. So alcohol, ether. So the last one can be tricky over here. So these molecules, the images of these molecules, I either made myself or took from Wikipedia. And this hydrogen might be confusing some of you. I think this picture I took from Wikipedia. So what this actually is we have a carbon chain that ends here. You can get rid of this. So what do we call a double bond oxygen at the very end of a carbon chain where there's no more carbons attached to it? It's at the end. And I'll give you a hint, it's not a ketone. I like this one. Aldehyde, exactly. So the only, again, it depends on, what book you're using or what internet site. This H is just there to really emphasize that this is the last carbon on that chain or branch. Remember, the magic number of carbon is 4, right? If you can remember that, you'll go a long way in this course. And this carbon right here has 1, 2, 3, 4 bonds. So the reason that Wikipedia put a hydrogen there is to really emphasize, really show that this is the end of a carbon chain. There's no more carbons here, right? Anyways, aldehydes are probably the trickiest one to see. And every year somebody might call it a ketone, and they're unfortunately whoever did all these naming rules decided to be a little tricky. So cysteine, this is an amino acid. So this is found in your body. One of the major building blocks of proteins, I think. I'm not a biologist. I haven't done a biology course in 15 years, but this is a very common chemical found in living things. And we have 3 functional groups here. Whoops. 1, 2. Don't mind this wedge. The wedge is showing it in like kind of 3 dimensions, but it's just a bond. And then 3. 1, 2, 3. So anyone in the chat want to let me know? You can say out loud too. You don't have to type it. Amine. Yep. Perfect. That's one of them. This is, if you have your notes in front of you, this one is one of the last ones we did. We have a carboxylic acid. Thank you, Naim. Cool. And one more. And again, this is in your notes. It's one, I think it's the second last one we did in your notes. I don't know if you have your notes in front of you, but I'm not surprised some of you might not know this right away, because I don't think you guys did this in 1121. And a thiol. Thiol. And so Saif, if you notice how you spelt it, if you did that on a test, Thoil, I wouldn't mark you wrong. Like, I don't care about spelling. Other people might, but I don't care. Yeah, Thiol, Thiol. That really no problem. And I didn't mean to point you out. Most people are spelling it wrong, but yours was a good example of you were so close that I couldn't take off a mark. I mean, it's I know that you know what it is. So really the only time I'm going to be picky is like amine. You can't call it an amide. Yes, no problem, guys. And about spelling, on your test, you will have this sheet in front of you, this functional group. I'll call it a cheat sheet. I guess I shouldn't. It's more like a data sheet. And the spelling is all there. So you guys, it won't be an issue at all for spelling, I don't think. Cool. Okay, it's September 10th and we finished chapter 1, the shortest and maybe easiest chapter. You will see these questions again, okay, specifically on your first test. I'll have an assignment for you guys early next week, and the assignment will cover some of this as well. And I also have worksheets I can put online. So between the assignments and worksheets and labs, you guys will definitely be ready for your test. The assignment, it will be online, and it'll be basically multiple choice because of the limitation of D2L. And I will have that for you Sunday. So on Sunday, I'll be putting an assignment up, and you can take the most of the week, if not the whole week, to do that assignment. But the assignment on Sunday will cover chapter 1, and it'll be D2L, multiple choice or fill in the blank type things, and it'll be very short. So help you. And I will have some worksheets up as well. Okay, so what time is it? It's 1 p.m. So how about this? I know it's the weekend is coming up. Let me just introduce the next chapter, kind of give you what would they, like a trailer, a premiere, a prequel? No, I don't know. In English or literature, they would call it like foreshadowing. I'm just going to show you what's coming up in the next probably few weeks. I say few weeks because chapter 2 is one of our longest units next to chapter 5. So let me open it up and I'll share my screen, and just give me 5 minutes and I'll just kind of give you an introduction and you're free to go. I'm sure some of you have class after this, but oh, whoops. Somebody in the chat just said, could I see example 1.6? Yes. Hold on, let me go back. Can you see my screen? 1.6, we had two functional groups. We had an ester and we had a carboxylic acid. Okay, that was aspirin, two functional groups, ester and carboxylic acid. All right, here we go, chapter 2. Share new screen, here we go. I talk to myself, don't mind me, I'm crazy. Okay, unit 2. I think a lot of us might be talking to ourselves now after this quarantine. So unit 2, alkanes and cycloalkanes. This is really, next to chapter 5, this is the most important unit. And the reason I say that is because, sorry, I'm just laughing at the chat there. The reason I say that this is the most important unit is we will learn, well, next to chapter 5, we will learn in this chapter naming alkanes. And the thing about naming organic compounds, if you can name alkanes with a couple little tricks, you can name alkenes, alkynes, and all sorts of different organic molecules. Aromatics are a little different, but if you can name alkanes, you've got naming almost perfected, cycloalkanes included. So I won't do too much of this today, but maybe I will just introduce some things. So let me just see here, definitions. Okay, I know what, I'll just do maybe 4 or 5 slides and we'll call it for today. It'll kind of get us warmed up. So I defined this in chapter 1. The first section is definitions. One of these definitions we did in chapter 1, of course, a hydrocarbon. It's a compound, it has hydrogen and carbon. Okay, there's lots of different hydrocarbons. There's aromatics, alkanes, cycloalkanes, alkynes, but they're all different based compound, different types. They have different properties, different boiling points, different reactivity, and that's kind of what we're going to get into. So I love this picture. This is an old, an old black and white picture of an old oil drilling. Maybe they call it an oil derrick. Maybe an old operation. This was probably somewhere in the United States. And most hydrocarbons are found on Earth in crude oil. And the discovery of crude oil and the properties of it and refining it literally changed our lives. So hundreds of years ago, when you were on the ocean in I don't want to say pirate ship, but a big British ship sailing across to North America or something, obviously they would have to have some form of light to see in the nighttime. And I know in London or in the UK, a lot of the source, or if not all of the sources for lamps was oil, but not what you think. It was whale blubber or whale fat. So they would go out, kill this giant animal, beautiful animal. I love whales, and take the fat from the whale. They call it blubber. And indigenous people, like where I'm from in North America, the native people have been using things like oils from animals for thousands of years. So the English would do it with whale blubber. So then 1800s, 1900, like late 1800s, early 1900s, people started drilling for oil and realized we don't have to go out into the ocean, kill a giant animal and take its fat for a fire. We can just drill a hole in the ground and use this black stuff. Then fast forward 100 years, we're turning it into plastics, into medicines, into polymers of all sorts. So, hydrocarbons have literally changed the earth, right? We wouldn't have plastics without it. We wouldn't have some drugs, like pharmaceuticals, without it. It's amazing, and hopefully, as time goes on, we can be a little bit better with it and maybe a little bit more environmentally friendly with it. But it's an amazing resource that provides energy. It's very cool, very very cool. So I know you guys knew that, but it's just, I don't know. I find science pretty cool, I gotta say. So I think maybe I'll stop here for today because it is Thursday, and I mean, this is getting into a lot of work or explanation. So maybe we'll pick this up on Monday. I think I have you. Yeah, Monday at 3:30. We'll talk a little bit more about saturated versus unsaturated. And then what we'll really get into is physical properties and the big one, naming. Huge, so important. Nomenclature means naming, but anyways, the smell of the weekend is good, and I hope everybody loves science. That picture does look a bit dreary. I think any pictures of the old, like 1900s, everything's so grimy and dirty. They didn't have showers as like we have today. So have a good weekend, everybody. There is a lab next week, so Tuesday morning. I don't care what you do next week. Come to the lab. Be in that lab at 7:30 in the morning. So have a good weekend. Wash your hands, wear a mask, stay safe. I'm going to stop the recording now. So any questions, let me know.